Hi, thanks for watching ABC News Live. I'm Will Reeve, and we have some big intergalactic news to get to. A story coming out of the scientific community in which astronomers say they're hearing signs from deep space. They're not sure what they are. It's only the second time in history they've heard these signals, and they're not ruling out aliens as the cause behind it. Of course, that's something we're going to want to know a little bit more about here on Earth. And for that, who better to educate us than two of the leading experts on this issue from SETI, the Search for Extraterrestrial Intelligence. We have Seth Shostak and we have Dr. Hakeem Oluseyi. He is a professor and works with NASA. These are two people very smart, very clued in. First thing I want to get to here is what exactly are these signals, these fast radio bursts from deep space that the scientists have heard?
You take it, Seth.
All right. Okay. I think that the answer to that is we don't know the answer to that. All we know is what the signals look like or sound like if you're kind of into audio, right? They're called fast radio bursts because astronomers are very unimaginative when it comes to naming anything. So they're a bit of radio noise that goes right down the radio dial. It's like a slide whistle. If you could hear it, it would be like that, but in a tenth of a second or less, an eye blink. And we've found 60 of these things. This latest one, it's interesting. It's the second one that's been found that not only does it make this slide whistle sound once, but it repeats. If you go back a couple of days later, you might hear it again. And that makes it very interesting.
So, Dr. Oluseyi, if this is indeed the work of extraterrestrial life, what's next? Where do we even begin with this? If we aren't ruling out aliens, like what could it be?
Well, the signal itself tells us something about the origin of the signal. What we do as astronomers is we learn to interpret light. So one thing about these events is that they're fast. So that limits the size of the source. For example, the sun, it takes light about 4.5 seconds to travel from one side of the sun to the other. So if you are a distant observer and the sun were to suddenly brighten and then fade again on a time scale of about 1/10 of a second, you won't see that because the light from the near side of the sun will reach you first, and then 4.5 seconds later, you get the light from the far side. So the fact that these things occur so quickly tells you that it must be a very small region that they're originating from. The second thing is if you look at light traveling through matter, it leaves an imprint on the light. As an example, when light travels through the glass of a prism, blue light is affected more strongly than red light. So the light spreads out and you get a spectrum. When light travels through the atmosphere of the Earth, again, the blue light is scattered more strongly, and so you see a blue sky everywhere you look. And so when we look at this phenomenon of how the light gets affected as a function of wavelength, we call that dispersion. We can tell something about the environment that the light passed through. And so the source of these particular signals appear to be in a place where the matter is highly ionized, what we call a plasma, right? And so it has to be hot. And it also appears that there are very strong magnetic fields. So what would aliens be doing with such an environment? They'd be getting cooked to death. So I'm not so sure if it's aliens.
Okay, well, yeah, we hope that no one anywhere is getting cooked to death. Let's break this down into terms that the layperson can understand, starting with deep space, Seth. What is that? Where is it?
Well, deep space. I mean, it's not that, you get in a rocket, you go into space and you pass a sign saying last gasp before deep space. Space is defined to begin at 100 kilometers up. That's about 60 miles up. And if you go beyond that, according to somebody at NASA, you're in space. But deep space simply means very far away. Now, the interesting thing about these fast radio bursts, aside from what has already been mentioned, they're small and all that sort of stuff, is that they're very far away. That we do know because the ones that repeat give us enough info that we can figure out where are they coming from, right? That's what you want to know, where are they coming from? And the first one that was found back in 2012, it's coming from a tiny nondescript galaxy 3 billion light years away. 3 billion light years, that's a lot of light years. A light year itself is like 6 trillion miles. So it's very, very far away. The second one, the one found recently by the Canadians, 1.5 billion light years away. Now, could that be aliens that are, in those galaxies very far away, and they have some need to get in touch, right, with these very short radio bursts? Well, maybe, but two things. First, every time we find something in space we don't understand, we blame the aliens. The aliens are the universal bad guys for everything, whether it's quasars, pulsars, the hexagon on Saturn, the tabby star, you name it. Something that we had never seen before. There are going to be people who say, you know what, Bob? It's aliens. Well, I don't think it's aliens. And the reason is we found more than 60 fast radio bursts. Most of them don't repeat, but we found 60 of them. So they're all over the sky. So how did the aliens over there get in touch with the aliens over there, billions of light years away, and tell them, hey, you guys ought to be broadcasting fast radio bursts? It's like, I go to a party and everybody's dressed the same. It's not very likely.
So then how do we, Dr. Oluseyi, how exactly do we collect these sounds? This sounds complicated.
Well, radio astronomy is a very mature field right now. The people like Seth and SETI, they run radio observatories, and they're all over the world. And so this is just a radio signal. And the key thing about this one is, it's so fast that at first it was missed, right, in real time. It was found by looking back at data, and then you had to convince yourself that it really is a real signal, right? We talk about a signal to noise ratio in science. So for example, imagine you have a flashlight, right? If you're in the complete darkness, okay, I see that there is your flashlight. Now imagine that your flashlight it's daytime and there's a lot of noise. There's a lot of other light. How do I see your flashlight? Now imagine you have that scenario and you turn it on and off really quickly, right? In a fraction of a second. Then it makes it even more difficult to find. So it's a good thing that, we now have the ability to not only obtain the data by using very large telescopes that are, tuned to radio wavelengths all around the world, but we also have the capacity to archive the data, go back and look at it. And nowadays, we have these real-time alerts. Telescopes are scanning the sky at all times. And when something happens that's really interesting, it gets tagged. Other telescopes around the world will tune in. And so this science that is going on right now with fast radio bursts is really new. It's not something that has been known to exist for very long. So who knows what it is, but we often see these intriguing signals and then have to figure out what exactly is going on in the environment. And so the more data we get from other wavelengths of light, perhaps beyond radio if they exist, the better we can pin down what it is.
Seth, if you'll forgive the pun, in your work as a senior astronomer at SETI, have you had other close encounters?
Well, I wish we had. That'd be job security for me if I thought that some signal was worthwhile enough to follow up on it. We get signals all the time. This is not like a Hollywood movie. In a Hollywood movie, people are sitting around, wearing earphones, as I'm doing now, by the way, but, hoping to pick up a signal from the Klingons or something. But the facts are that we are very good now at distinguishing those signals that we get all the time from telecommunication satellites that are beaming data back down to Earth, or the radar set at the local airport, or a Stanford undergraduate prank, whatever it is, we can figure it out. So you don't get false alarms. It's kind of like Chris Columbus, right? 2 weeks out of Cadiz in Spain, and you can ask him, hey, did you find any new continents today? And he'll tell you, nope, just saw water today, and that was true yesterday. Yes, but are you close? And the answer is, how the heck does he know? We don't know if we're close. So we haven't found anything that was intriguing enough for us to, get up earlier in the morning to study it again.
But I've been told that in 1997, something happened of note in your world as a researcher. Could you elaborate on that?
Yeah, well, that's true. In 1997, I was at home having dinner. The boss calls up. He says, come on down to the Institute, which I did. I thought I was about to get fired. But in fact, we had picked up a signal that looked quite, it was passing all the tests. This looked like the real deal. And of course, I was there, waiting for the the Men in Black to show up. Maybe Will Smith. The Men in Black didn't show up. I don't know. I don't really think there are any Men in Black. I was waiting for the phone to ring from the White House. Something, right? Nobody was interested. It was rather an interesting experience that nobody seemed to care. And there was no policy of secrecy, right? The public seems to think that if we found a signal, it would be kept secret. That's not true. Everybody's on email, or they're texting their friends, they're writing on their blog. Nobody was interested. 24 hours later, we figured out what it was. It was just a satellite, actually, man-made thing. But for a while, we thought it might be E.T., and that was pretty exciting because I was so nervous I could not sit down. I had to just sort of walk around and, ponder what I was going to do about all the dinner engagements I'd scheduled for the next month.
So now what should we be excited about or taking note of with this new discovery, Dr. Olashey?
Well, I tell you, one of the things that we should keep in mind is as we think about this notion of extraterrestrial intelligence potentially and what this signal may mean, we have data now that we didn't have 20 years ago, and that is observations of lots of other planets that orbit other stars. So we have an idea of what's kind of normal and what's not normal. And one of the things that we see is that a planet like the Earth is really not normal. And here's what I mean by that. We have a very thin atmosphere and we have surface liquids. And so that biases us. So as we stand here on Earth, we look up at the night sky and see stars every night. Would that be a common experience? Well, if we look at the 8 bodies in our solar system, the 4 giant planets and then the 4 smaller terrestrial bodies that have atmospheres, most of the atmospheres are really thick or nearly absent. For example, Jupiter, Saturn, Uranus, Neptune, these things are called gas giants because there's mostly gas, right? But then if you look at the terrestrial bodies like Venus and the moon Titan, their atmospheres are incredibly thick. If there was a civilization on a planet like that, they might not even know there are stars because the starlight wouldn't make it to the surface, right? And so we're biased to think that, aliens would be like us. Now, what do we need for life? We need water or liquids. And so we find oceans all over the place, but typically they're not on the surface of the planetary body. Only Earth and Titan have that feature. Most of them are locked under kilometers of ice. So if aliens do exist, what are they most likely to be like? Would they be like us? Chances are that would be a minority of the cases. So what we are excited about when it comes to this type of observation is that it's something new. And so every time we see something that we've never seen before, that's an opportunity to learn something new about the universe. And as clever as humans are, when we learn new things about the universe, we also take advantage of that knowledge, right, to improve our lives in some way. And also, as we develop new technologies to better understand the things that we observe and discover, we also take advantage of that in order to improve our lives here on Earth. So, the thing about fundamental science is it pays off in big ways that you can't anticipate at the beginning, but it almost always does.
Seth, when our viewers head off having watched this segment and want to tell their friends, family, coworkers about what they've learned, how should they relay, what should they say to all these people about this discovery that's been made in the scientific community? What's the takeaway?
Well, I do think this will make interesting dinner conversation, actually, because this is one of the hottest topics in astronomy today. Astronomy is a lot about exploration. Astronomers don't get paid to go up to the dome and look through a telescope at the moon. Hey, the moon's still there. No, they're looking for new things, and this is a new thing. Okay, fast radio bursts. We've known about them for about 10 years. We still don't know what causes them, right? So it's a big mystery, and they can certainly talk about that, and you can find all sorts of stuff on the internet about fast radio bursts. I think that it's a safe bet. In fact, I'm willing to, bet a cappuccino that, in fact, within a year or two, some clever theoretician is going to figure out what fast radio bursts are. That is to say, what makes these fast radio bursts? I don't think it's going to be aliens. But there's also this. We are trying to find the aliens. I mean, we use our antennas every day. There are other people who are using antennas every day to try and eavesdrop on a signal that would tell you that there's somebody out there at least as clever as the residents of Passaic, New Jersey, or something like that, right? So we are trying to do that, and that experiment is getting faster all the time. There's very little money for it. There's no government money, but it's getting faster because of the improvements in technology right here in the Silicon Valley where I am. Okay, so I think that it's something you could talk to your buddies about and say, you know what? It's very likely that we will be the first generation to find out that we're not the only kids on the block, that there are other intelligent beings out there in space.
Dr. O'Shea, what should I tell my buddies about as it relates to this?
Well, you could tell them that what is happening right now, that we're really starting to get a real sort of tangible feel for, is how important these dead star objects are that populate our galaxy and galaxies throughout the universe. So the reason why I bring that up is, earlier I talked about the fact that the signals appear to come from an environment with very strong magnetic fields. And so one of the places that we find that is around these dead stars called neutron stars. And you may remember that we were very excited not long ago because we saw the collision of two neutron stars. That data was gathered by gravitational wave telescopes. And that gave us an idea that, oh, now we understand the origin of a lot of the heavy elements like gold, right? It comes out of these collisions between neutron stars. So I'm willing to bet that the most likely origin of a signal like this has to do with neutron stars, potentially, or black holes. And you know, this is a hot topic. We're just now getting an appreciation for it. So bringing up the topic of neutron stars around dinner is awesome because they're so exotic, they're so different, they're super dense. 2 times the mass of the sun in a volume smaller than a city, right? You can imagine what a teaspoon of this stuff would be like. And so the bodies that occupy the heavens are so spectacular, they're so exotic, they're so interesting, and just, you know, contemplating their nature, because we've never seen one up close, right, is a wonderful night of discussion in and of itself.
All right, Dr. Hakeem Oluseyi, Seth Shostak, thank you so much for joining us, making us smarter here on ABC News Live as we explore this astronomical mystery. I'm Will Reeve. That's going to do it for us for now here, but don't forget to download our app, the ABC News app. It works anywhere on Earth and maybe even in deep space too. Take care.
Hi everyone, George Stephanopoulos here. Thanks for checking out the ABC News YouTube channel. If you'd like to get more videos, show highlights, and watch live event coverage, click on the right over here to subscribe to our channel, and don't forget to download the ABC News app for breaking news alerts. Thanks for watching.